Hi, I'm going to be going through question 7 of round 2 of the Maths Teams Olympiad. This question was quite nice. It was sort of algebra-y, and it was fairly straightforward, I think. I'm going to be going over the solution now, and yeah, let's get into it. So we've got this function f of x equals x squared. Let me get a thicker pen, like so. And we want to find out if it's possible to form a parallelogram. So a parallelogram is made of 4 points. It's a quadrilateral which has 2 parallel sides, 2 parallel pairs of sides, and the side lengths are equal. The fact that they're parallel is quite important. So that means if you have a coordinate axes and you have 2 pairs of parallel lines, they'll have the same gradient, which means we can do some algebra and some maths on this equation. So if we've got, like I said, it was a parallelogram, it's quadrilateral, so that means it will have 4 points. Let's just try draw a little brief parallelogram, or something which looks like a parallelogram here. So here are the 4 points. I'm going to call it A, B, C, and D. And I'm going to join these up real quick. So I'm joining A to D, and then it sort of looks like you can get another parallel line there, B to C. And just from inspection, I can see these last 2 lines don't look parallel, but we're yet to prove it. So we can swap around these points and we can choose any 4 points. So let's have the x coordinate of A, B, C, and D to be A, B, C, D, respectively. So we can assume that A is strictly less than B, strictly less than C, strictly less than D. These are strict inequalities because they can't be equal to each other, because 2 points would be on the same point and it would no longer be a parallelogram. So this is a strict inequality, and that's quite important, and I'll show later why. So let's first assume parallelogram can be formed. Parallelogram can be formed. This means the gradients, so the gradient of AB is equivalent to the gradient of CD, and the same is for AD and the gradient of BC. So the gradient of AB, well, that's just A squared minus B squared over A minus B. So this is the change in Y over the change in X, and this is equal to A plus B. So this is the gradient of AB. For a gradient of CD, well, this will be change in Y, which is D squared minus C squared over the change in X, which is D minus C. And this is D plus C. And the same logic goes for AD. This is just going to be, the gradient of AD is going to be A plus D, and the gradient of BC is just going to be B plus C. And we've got equality here. A plus B equals D plus C. Well, we can see we've got equality formed when A plus B equals D plus C, and when A plus D equals B plus C. We are going to sort of ignore this inequality. We know it sort of happens, but we're going to look at this one. And we can see this can never be true, because A plus B, which are both less than C plus D, it just doesn't make sense. Pardon me. We can write this like this: A is always going to be less than D, and B is always going to be less than C. So if we add these equations, A and B is always going to be less than D and C. They can never be equal. Therefore, a contradiction has been formed. Therefore, there can be no parallelogram. Notice here A plus D and B plus C. This can be possible for them to be equal, and that's why you can see here the gradient of A and D and the B and C looks like it can be parallel. However, for the gradients of A and B and D and C, you can see from this little statement here, this little statement here, contradicting this, that it's never possible for that to happen. So yeah, that's a proof there.